All right then. Well, I'm going to mute
Sorry,
this.
Matt. I wasn't prepared for that.
That's all right. I didn't quite know what the best option was, so I thought just doing it YouTube would be the best way to do it. So I'm going to talk about myself for a little bit, um, and basically I have been told to call myself a creative technologist, after which many people at UAL do call themselves this, I think. So, but basically, what that means is that I've been working with creativity and technology for a long time, and I used to work for Sight Gallery years and years and years ago, probably before a lot of you guys were born, actually. And I was the technical manager, and I worked with various different artists to create all sorts of different artworks, um, like using moving image and interactivity in different ways. And while I was there, I was in charge of running the Innovative Innovation Lab, and it was a knowledge transfer hub. And I took care of everything digital, anything with a plug on it, really. So it was basically just helping artists and doing stuff for them. We had lots of electronic media, including streaming. When we first started doing streaming with Susan Collins, we had this thing called Transporting Skies, where there was a camera put in the ceiling in Newlyn. Oh, sorry, yeah, a camera pointing at the sky in Newlyn, and then a camera put in a bowl. And as you looked into the bowl, your face would come up on the ceiling in Newlyn, and in Sight Gallery it was on the wall because it was too low, the ceiling. And in these two examples, we would take in new artists, people who had just finished their masters, and also some established artists. So Esther Johnson here, I built her a little camera that went around on one of the tallest buildings of Sheffield over and took pictures every 7 seconds, and so we ended up with like a 30 frames per second video of using actual film, of the top of Sheffield. And Stephen Gray at the bottom there, he took out. I can't go backwards. It's going forwards. Come on, right, Okay. So here, Stephen Gray, he took out all the bits of scenery in Wizard of Oz and just put all those together. So you got to get a nice feeling of what it might have been like within the Wizard of Oz. We also took technology out in a caravan and all these other kind of weird things. Anyway, I was working there for 8 years, and then I moved over to Holland and I did my masters at between the Royal Art School of The Hague and in the Leiden Institute for Advanced Computer Science. Then I moved into London to work at to work at Queen Mary to do my PhD, and then I was working at Goldsmiths and RCA and Imperial, and now at UAL. But I've got a bunch of practice stuff that I did during that process. This is a robot arm controlled by a glove, but instead of using sort of pointing where the glove would go, it uses the different sensors to control the arm. So instead of you controlling the robot arm as you would kind of want to control it in real life, you have to embody yourself within the arm to control it. And I've got a little video of that here. 2011. I took one of these very basic kits that you can buy from Mappins, and
Not anymore.
took away the boring controller and made something a bit more interesting.
which is a glove which has a safety switch here, an accelerometer here, 3 flex sensors, and with these simple interfaces I can completely control the robot arm with gestures.
Okay, so as you can tell from this, it's just using very basic sensors and going straight into the Arduino to directly control the arm, and it was called an Introduction to Digital Media Techniques, and so that's why we learned about accelerometers and data. And look at that mess! Look at all those pins stuck in there. You shouldn't do that. This is a prototype, and it's okay for building prototypes and for testing stuff, but that's all. Okay, so then, as I said, I moved over to Leiden, and in Leiden we were doing all sorts of different media practice. So if you want to ask me about any of these kind of things, you can book a tutorial and I can talk you through some of the stuff that's there. And my final project there was this, the Hapti harness, which I spent a few months, and I think I told you before, I spent like €600-700 on just kit for this. And this is a harness that you wear that's got vibrators all over the place. And the way that I tested this was by just putting it on people, not telling them what it is doing, and then asking them what they thought it was doing. But what actually it did was it was kind of a wayfinder. It had a GPS built in and a few other bits and pieces. And it was a lot of fun to build, but here's the schematics that I built way back then, and the first thing to do is to test. And so in the bottom left here you can see that I've connected up all the little bits and pieces. Here I've got a distance sensor, a magnometer, which is like a digital compass. I've got infrared, 2 infrared distance sensors, which were a bit useless because obviously if you're shining infrared into the sun, you're not going to be able to measure the infrared coming back from anything that it hits. There's a GPS module there, and this is the Arduino FIO, which had a nice XBee connector on it, which allowed us to do nice data packet sharing between the computer and the Arduino. So there was, in this box, which is so handsomely designed, as you can tell, these are 2 shift registers, which you learned about last week. These are the TLC 5940s, and if you look at the top right picture here, that's how they're connected to all the vibration modules, which have got a diode and a capacitor on them to try and capture the electricity that's coming back from a diode. So one of the things I wanted to talk about in this presentation was the mistakes that I made, and the problem with this was that the electricity coming back into the TLC 5940 was too much and blew the actual chip. So I ended up just replacing the chip quite often, and it didn't quite work out why. But after I'd done the presentation, I kind of realised that we generate quite a lot of electricity ourselves just walking around. Then on top of that, I hadn't calculated for that in my diodes and my capacitors. I just calculated for the voltage coming back from the vibrations that are still spinning. So that's an interesting finding that held me back. Well, basically blew up a lot of chips. But yeah, as you can see, we've got all those things connected up, which gives us a nice framework to program. Now, as you can see here, I'm doing loads of testing, and it's basically lots of serial printing, and this is what you have to do in order to work out what the hell's going on a lot of the time. As much as you plan things, you're constantly having to debug. There was also a power management issue, so there was a separate board for managing the power. So the standalone app was basically, I read about this guy in Germany at the University of Arnhem, and he wore a belt that was constantly vibrating in the direction of north. And so when you were doing that, when you're wearing that, you can constantly feel where north is. And he was wearing it for 3 weeks, and every day, and then when he took it off, he found it was quite dyspraxic because his brain had got used to the idea of getting that information. And it's quite interesting that touch becomes it rewires the brain so quickly. And so I started playing with that later in my PhD. So it could also be used as a navigation tool. So if you held down the button, it would remember where you are, and then just vibrate back into that direction until you get there. And then when you get there, you get a nice massage. And that meant also that we could then proceed building the treasure hunt mode, where I just got people to go around Leiden and try and find different locations that I put in from. Actually, it was from the locations on the GPS, and I gave it a bit of an extra, like buffer zone, but because there was lots of canals and stuff, it was kind of important that we enjoyed that people were safe. So we followed them around, and we learned a lot about what this kind of medium could be. And then when it was wired up to the computer, we could do extra things. So, and a lot of these weren't very successful. Like the first obvious thing was to build like a hapticizer. So as you listen to music, it would vibrate at different speeds. But one of the things that we learned there was that obviously you need a lot of power to get the vibrations moving. And once they're moving, you can change it quite quickly. But if they're not moving at all, there's a delay of like 50 milliseconds, which really, when it comes to touch, you really need that speed. And so once it's running, you can change the speed up and down quite easily. But until then, it doesn't work so well. And the same goes for when you're trying to avoid objects, like, trying to get the motors to speed up fast enough in order for you to feel as though you're going to hit something. This is all in MaxMSP. We used a serial interface that was manual here, so you can see underneath the picture of the torso there's lots of zeros, and then there's lots of other boxes, and basically that would be sent off to the hapti harness, and then it would interpret those and make the motors spin as they should do. And on top of that, we built like a memory for what motors should be spinning when, and then we could match that with a film. And so I matched that with a film, which I can't show you. The best way to do this is to actually experience it, which of course we can't do right now. But it really does feel nice when you're wearing this stuff and it's tight and it starts vibrating all over the place. I'll just show you the prototype testing video.
It's very comfortable.
Is it?
It's very relaxed, yeah. I feel it, but I don't feel it like it is something extra, like more like jacket or...
Okay.
Yeah.
This is the suit that avian species wear to guide them the right way.
I'd like to say that I really like the gentleness of the vibration. It feels the whole device feels very light and very comfortable. And it does give you a nice tingle. It's a tingling sensation. It is definitely that way. Whatever it is, it's that way.
It draws you to the pavement, it keeps you off the road.
It was as if it was asking me to find a way, okay? Because the first one was directing me to this direction, and now the other one is more like this direction, and then somehow it was between this direction and this direction. And when I follow the way that it asked me, so then I feel it on my stomach, that like as if I am in the right track, okay? And the direction is right.
I don't know, I'm feeling the vibrations, there's something coming up somewhere. So if I walk towards a wall, is it going to tell me there's a wall in front of me?
So doing this, we just asking people what it is that they thought it was doing, gave us loads of ideas on what we thought it could do, and this is kind of a really nice way of prototype building. And like I said, you have to look after people so they don't walk into bikes and try and cross roads and stuff. okay. I cut it there. There was another bit, but yeah, we'll show that another one. So that got me onto my PhD program, which was another master's, and then a 6-year PhD research. And while I was there, I was really into this idea of using haptic technology to communicate in some way. And so I thought about what could we do with that. And one of the things that I thought about was giving agency to people in nightclubs. For obvious reasons. So I went up to the Culture Lab in Newcastle. It doesn't exist anymore, it's called something else, but a lot of the people who were there are still there doing bigger research stuff. It would be quite nice to make a connection with them at some point. And so I built this. This is actually a cover for a Apple Nano years and years ago, but what it does is it covers up this wax. Now this is a system that was built by the Culture Lab, and it's a wireless accelerometer, and they used it for all sorts of stuff, like just recording people using utensils in the kitchen, for example, to see if they could make any sense from the data. Using machine learning and stuff, you could kind of work out whether someone was whisking, or what kind of styles they were doing, and looking at different ways that people might cook. And I thought, well, okay, there's a spare port on this, I'm going to use it. So I added a vibrator and a light to it, and then I used all the live data of the accelerometer data and sent it off to DJs and VJs and to see what they would do with it. And it turns out I went to a few of the hack days, some in London, some in Newcastle, and asked and some DJ meetups and VJ meetups. The DJs weren't interested at all. DJs in this kind of session are gone completely in the wrong direction. They don't want people interfering with their music. They like to have control. It might be that you could offer something like changing the bass or something like that, but it was the VJs that were really interested. If you stuck these things, for example, on guitars or on drumsticks, then you could get that live data straight into something. And in this case, again, I went to Max MSP, and this was an example for the DJ. Whereas if people were dancing around enough, then they would get a rewind, and if it was offered, then they would start replay the song. But as you just saw in those last couple of slides that I flicked past really quickly, it was actually built in custom hardware and custom software using some pretty intense tools. Microchip is a FTDI programmer that allows you to program chips. Now, all this kind of stuff you can do now in Arduino, so you don't need to go that deep. But what's really nice is being able to get this kind of data into something called OSC, Open Sound Control, which allows you to then connect to virtually anything over the network. So yeah, that was my plan, like a slider of agency between the DJs and the audience members. So yeah, there they are, spinning around. And this is getting really, really popular now. There's a Daniel Eagleman is kind of like the Dr. Brian Cox of America for neuroscience, and he's been developing these techniques not only for the blind people, but this is a live jacket that you can wear that gives you information about the stock market and stuff, and so you could literally feel the data of what's going on with the world and make decisions, because that touch interface actually grows new neurons and new pathways in your system, in your brain, after enough training, and then you could interact with it in whatever way you wanted. So it's scary to think where this might have gone. We don't really know. Anyway, I want to get back to more simpler projects. This was a very, very simple Arduino project that I built with a friend, and it uses a potentiometer to just change the direction of this boat that he built in the gallery, and as you move the potentiometer, it sends that data to the computer, and the computer then changes your direction within a virtual world, and all it does is play the radio stations that have been freely broadcast from Shoutcast in the area that you're gliding through on this virtual boat. So sometimes you only need the minimal amount of technology to be able to do something quite interesting. Susan Collins is someone that I've been working with for a long time. She's brilliant, and she used to be the head of the Slade Art School, and she got commissioned to build something for the White Night in Oxford, which is like their it's a celebration as the clocks go back to celebrate light and stuff. And so we lit up the Radcliffe Observatory, and inside there is one of Galileo's telescopes, and usually no one's allowed in there. But so what we did was install some DMX lighting, and then it was up to Susan to come up with the kind of creative ideas, and she wanted to use the weather. Since on the outside of this building there are lots of different what you call them, not statues, but those things that represent the weather. So there's lots of and so there's 8 different ones that are representing different weather conditions. And so she started to think about using the weather as a way of lighting up the building. And so there was a weather station there, but it didn't work very well. In fact, it didn't work at all. And so I built her another one out of the Arduino. I'm wondering if there's any. So this is the one that was there already, and this is the one that I built. And you can see it's a kind of a simple system that you can get from online, you know, and generally they come with like an LCD screen. And I was going to try and sniff the RF232 packets that were going, the 433 megahertz signals that were being sent through the air. I tried that, but it wasn't giving us very much data very quickly, and so I decided to plug all the sensors independently into an Arduino, and then I could sense them how I wanted. And then I attached that to a Wi-Fi board, so that I could send that data up to a Mac Mini that was again running Max MSP, and telling me which direction the wind was going, how fast it was. And this little white bit in the picture halfway down is a bucket, and it collects water, and then when it's collected a certain amount of water, then the bucket tips it out, but at the same time it pushes a button, so that way we can measure the rainfall. And so using this data, we then lit up the observatory with over time. And so it ran for like 2 weeks, and there was a white light in there that would, these are all DMX fixed lightings, they didn't move around, but we could program them to come on and off and change colour and such, depending on the data that was coming in. So the Wi-Fi was sent to the Mac, the data was sent to the Mac, and then the Mac made all the stuff. Oh, let me just get a drink of water. So I'm going to take questions about all this stuff afterwards. This is Kip. Kip is great. He wanted to build something for the new gallery that was opening up in London, the Science Museum. No, the Science Gallery at London Bridge. And so he got one of those devices that you can put coins in and recognise what the coins are, and then it spit it out again. And so he asked me if I could help him. This is in Goldsmiths. And basically you put the money in, and it sends this little device that's connected. It's kind of black and it's got wires hanging off it. That sends a pulse for different types of coins that you can put in there. So if it's a 50p, it might send 8 pulses. And so the Arduino counts those pulses, and then it would do something. And so what Kip wanted to do was build this kind of imaginary journey that the coin would go on before it spat back out at you. So in order to do that, we needed to stop, once you put a coin in, we needed to stop you from being able to put another one in so it didn't jam the system, and that used a little servo. Then it would hold the coin and then trigger an MP3 player. So we've got an MP3 shield here, and so I haven't got any of the sound files to play you, but if you imagine, it's kind of like going through, like when you hear a ball going through a pool table, it goes around and round and round. And basically he would play with the idea of the more you wanted to interact with it, the longer it would take. And so it talked about the idea of time and money and perception, because obviously while those sounds are playing, you don't really know what's going on, and then it would just spit it back out at you, and then allow you to put another one in again. With Ruth and what's his name? Bruno. So it's Bruno Martelli and Ruth Gribson. They built this system where they wanted to tell the story of White Island, which is a book that was written by a guy he was one of the first people to explore in a hot air balloon, and so they built this virtual world for you to go into. But what they really wanted me to do was to help them work out how to control it. So if you imagine in the gallery you've got a hot air balloon basket that you would stand in, and then you don your 3D goggles and you can get inside this world. And now you've got a rope hanging down. Now needed to use that rope to control the direction and the speed of where you would go in a hot air balloon. And so he tried many things. He had like various different pulley ideas and stuff like that. And then I was like, well, hang on a minute. Wherever this gets installed, we could just install a proximity sensor and work out how far the ceiling is away from the top. So the rope is attached via 2 strings, so it's quite taut. And then use an accelerometer to work out which way it's been pulled. So if you're pulling it down, then the proximity sensor will tell us that it's changed, and if you're moving it left and right, the accelerometer will tell us that it's changed. And then instead of getting really complicated and working out how to move data around in Unity, we ended up just making the Arduino itself become a keyboard and just press the AWS, the gaming buttons to move around. And so you can reprogram the USB output of the Arduino to be something else. I mean, we tried quite a lot of things, and this worked really, really, really well. And also, on top of this, they wanted the fans to be blowing, so you got this kind of like feeling of wind. So the information was coming back from the Unity system using, I think it was OSC, and then we had a processing sketch that would work out what fans should be blowing, and then I got the processing sketch to talk to another Arduino with some snubbers and some other 240 volt relays to turn the fans on and off. So here is this is in their studio. Here is the accelerometer and distance sensor Arduino that's just plugged directly into USB. So as you can see, you're moving that around, and then the fans will come on and off, and they actually work really effectively. You can get quite chilly in this installation. Which brings me on to Chris. Chris wanted to. He's got some really nice ideas about how we can help the homeless, because a lot of the time homeless people don't have an address, and so they're completely out of the system. And what he worked out was that there are a lot of addresses that are not currently being used, lots of boarded up buildings and things like that. So if he asked the council if he could use their addresses, then you could have a proxy address, and once you've got the address, you can set up a bank account, you can start applying for jobs, all that kind of stuff. Anyway, he wanted me to build him a system where you just push a button and it prints out a receipt of your address, and so you get this proxy address. So using one of these thermo printers and using a memory card, because we couldn't hold all of that information in the Arduino, we needed to store that on a EEPROM, and so we used an SD card actually, and we stored all the files on there, and then we could access it and print out randomly from a spreadsheet the address. And then we were like, so how do we get this to loop? And actually then I realized you can just press the reset button, and then it just prints once, and then it doesn't need to do anything else after that. And so the reset button became the activation button, which is another way of using interrupts. For Sarah, this is a bit more complex, but it's a nice system. So it's a nice way of being able to use existing technologies and sensors in new ways. So using RFID on the bottom of jars, you could insert, identify what were in the jars. And in this example, Sarah built for her PhD project a seed library, and it connects the community in Spitalfields Farm. You can go up there. I think it's that Spitalfields. It's maybe another farm. You can go up there and you can get asked to see this and use this. Basically, she recorded the community talking about the seeds that they are growing in the garden, and then use this system to get them to talk about how they grow them, where they came from, what you might cook with them, all those kind of things. And the system itself is running on a Raspberry Pi, but it also has an Arduino at the back, which in the end we didn't really need. But a Raspberry Pi is an Arduino was easier to just create an input to the Raspberry Pi. And this is how it worked. So you would take one of the jars and you would put it on the RFID sensor on the right there, and then this round thing that is on the left would spin round, and that's got lots of RFID devices, RFID nodes in it, and then when it spins around the RFID sensor underneath it, you can it changes the mode. And so if you can, I don't know if you can work out in this picture, but it kind of says like how to save the seed, who am I, why I grow this food, and so you can turn around this this palette, and it tells you the stories. There was a big problem with this, in that you have to really manage power on a Raspberry Pi, because if you just switch it off, it could be in the middle of doing something and it will fry your SD card, and therefore it will stop the system from working completely, which we discovered. So we had to build a shutdown script, and it had to monitor its own energy usage, and if it was if the battery was getting low or if it wasn't plugged in, then it would say, okay, I have to go to sleep now, and shut down properly. Otherwise it would just ruin itself. There's a bigger picture of these sensors, and as always there's some terminal open with Arduino and possibly processing, doing all the communications. This is an off-the-shelf system that I worked with Sophie Hoyle. It uses Bluetooth, but it's not very good, and it basically just measures your conductivity levels, which can be related to how stressed you are, because you start sweating when you get stressed, and so you can use that information to build up a data analysis. And so this one played various different videos using what did I use for that? Might have been VLC, but it could have been QuickTime something, I can't remember. Anyway, that all connected up. So she was wearing this during the exhibition, so the videos got very intense because she was quite stressed. This was at Space in London. Yeah, I wouldn't recommend using Bluetooth in any installation that includes the public, because this was a complete disaster getting it to keep connected. Okay, this is another system where it uses Arduino to play MP3s in the carts that you're driving around, and the MP3s in the cart would say things like, "You're horrible. You're not very good at this, are you? You're terrible." And then you would drive around this area in the back where there were all these videos that were all playing off Raspberry Pis, that would say things like, "Oh, you're great at this. You're gorgeous. You're the most amazing person I've ever met. You're fantastic." And so you were kind of like in between these kind of different ideas of what people might think. You might think what people think. Unfortunately, this got closed down because of one of the London terrorist attacks, but it was a really great exhibition when it was running. I worked with Sakamoto to build his Global Forest Symphony, which basically we worked with building data up from trees using the photosynthesis of trees, and so we put a rod in the ground, and then we put a nail in the tree, and then we took that information and used that information to build and saved it as a massive database basically, and then Sakamoto built from that data. There were trees all over the world. My responsibility was for putting them in Richmond Park and then sending the data over. And we worked with YCAM on this, so they built as you might do later in life, is build a little shield for the top of an Arduino. And also we had, so this shield was a Ethernet shield, but also did all the, sensing and stuff from the electrocurrents between the tree and the ground. And again, it's kind of, it was complex, but there was kind of an algorithm that they were using for this. One of the things I was going to say is it's really quite difficult to build your own hat for an Arduino, but if you do, get them made somewhere else, and don't try and put them together yourself. Unless, you know, at this scale, if you've got like 28 different locations that they all have to go to and they've all got 3 of them, I would just get them made outside, try and get a good budget. And also you need to protect yourself with anything that's going outside. You need to make sure that you've got like lightning protection. So that's what those big APC things are, is if there was some surge of electricity, it's not going to blow up the entire system. And so yeah, these were the boxes, and we put loads of, that's the other thing, is when you're doing stuff outside, the same with the weather station, you need to put these like gel packs in there to stop the electronics from getting wet, because if the electronics get wet, obviously that creates a circuit, and it can stop the whole system from working again. I worked with Sumi to save Walter. This is Walter, the embarrassing robot. It's not embarrassing actually. He tries to help you deal with embarrassment, and it was very successful, a part of her PhD project. But it broke, and so I fixed it, and so this looks terrible because it was a bit of a rush to get it working for the V&A exhibition while she was heavily pregnant, and so like there were just various moments where I could get to it and do stuff with it. But yeah, this is an Arduino clone, and it needed a new power pack, and it connects up to a Raspberry Pi. The Raspberry Pi does there's a camera on there, and it can detect whether there's someone there. I mean, if someone's there, then it gets embarrassed, and it starts the top of Walter kind of it glows, like gets all pink and red, and the fan comes on and it starts fanning itself as if it's embarrassed that it's been seen. This is going on a bit, isn't it? All right, okay. So I'm going over a bit. So this is another project that I did with Julie Freeman. She's a TED fellow and artist friend, who was also part of doing the PhD program that I was on at Queen Mary. And she wanted to use data as an art material. And so she found that really interesting, in like, how would you do that? Why would you do it? And what kind of data could you look for? And then she discovered that there was a big mole rat research centre at Queen Mary. And so she decided to put little RFID tags in the mole rats that were in their cage. And as you can see in the top picture here, they have like a cage that's built up with tubes. And you can tell where the nest is and where the toilet is and where they're all scurrying around, where the food is. And so that data was then turned into something like what's at the bottom of this image. And we used like various different systems. But the other thing that she wanted to do was to turn this back into, these are the mole rats. And you can see them flying around. The one with the orange on is the queen, and so she gives birth to all these, and they all huddle together.
Who's lovely?
They're all kept nice and warm, and so that data goes into a database. But we needed to record the environment of where they were at. This is what they look like in real life. So cute. So this is a little system that I built that fits in their nest, and so we wanted to detect, you know, what is it like. One interesting thing is that they still have eyes, but they're blind. They never get cancer. They get no vitamin D apart from what they eat from the soil. They're usually found in Ethiopia and places like that. Anyway, scientists study them for lots of different reasons, and now they've been studied for art reasons. And so to detect what things were like in their habitat, I built this really simple little system that just has a microphone and a heat sensor, temperature sensor, and a light sensor, and then that sends things off to a server. Also it was my first time playing with these little LCD screens, which I really like. So I did little printouts. That data was then turned into statues. These are kinetic statues built out of soft robotic material. So this is silicon, and there's a whole load of other stuff I can talk about with this. There was a lot of mistakes going on. For instance, when we're pumping air in and out, the idea was that you would have three, hang on, let me try and do my camera. The idea would be that you'd have like three inputs of air, and then if you're pushing air in one direction and sucking out the other, it would move the statue. But of course, if you don't build it very well, then it will explode in various different ways, as it did here. And so this is how we did it. We put some wax and then wrapped cotton around the wax, and then put that in a mold that was 3D printed, and then filled that up with the silicon. And then we used some silicon glue to attach some tubes, and then fill up the tubes with and this is a little machine. Fill up the tubes with air, I was going to say. And this is the little machine that I built out of Lego to just wrap the cotton around the wax things to speed things up, so we could build more statues. We needed to use really good motor controllers. These are the NEMA 9s. Oh, it says announcement for the end of your video. What's that mean? Have you cut me off? Okay, do you want me to stop? I will just stop there then. Basically, yeah, this was a massive system. Okay. All right, so after this video, we're going to take a break, and then we're going to do questions. So, yeah, again, Max MSP, and this was the whole system that would blow air in and out of the statues. And this was one of the statues that would be moving around. Now, it was really complex to build, but we did manage to get it into the New Scientist thing. And so, yeah, it's up there doing its thing. And so, yeah, that basically... Oh, yeah, that was the last slide. Let me go back. I was going to suggest that you can use this. Yeah, these are the things that I want you to really take in, is like do test your soldering, use decent connections, hot glue anything if it's going to move. If no one can see it, how tidy does it need to be? Don't be too pretentious about how everything looks. Memory is really tight, so use it really sparingly. and take whatever you can off the board. Plan out your system before you start building. Make sure that things are the right voltage and that you've got enough ports. Avoid using delay. Breakout boards are great for doing things such as like playing MP3s or taking in or using extra lighting systems. Comms can be really, really complicated, so think about that. Like how things are going to talk to each other. It also slows things down.